Assalamualaikum and hello everyone. So today we are going to present experiment 1. Firstly, objective. The purpose of the experiment 1 stability of floating body was to determine the height of metacenter by using the tilting method. Next one, introduction. Laboratory experiment 1 is an exercise in hydrostatics. It is designed to demonstrate the stability of a floating cylinder and to familiarize the student with the concept of buoyancy, metacenter, and metacentric height. A floating body is said to be stable at its position if it's returned to that position following a small disturbance. Theory. The knowledge on the stability of bodies such as floating ship is wider. As depicted in figure 2 here, a floating body can be stable even though the center of gravity lies above the center of buoyancy. This is true since the body rotates, the buoyancy force acts on the centroid of the new volume displaced, which then form a restoring couple with the weights. Hence, cause the body return to its original equilibrium position. However, for the relatively tall, slender body as shown in figure 3 here, a small rotational displacement can cause the buoyancy force and the weight to form an overturning couple, which lead to unstable configuration of a floating body. In this experiment, the stability of Puntu is determined with the CG at different heights. If a horizontal weight is moved to a distance from the center, the Puntu will tilt. The angle of tilt can be measured by using the Plumb box. The equilibrium condition of floating body can be determined experimentally as follows. There's a three equation: overturning couple, right-turning couple, and four equilibrium condition. The results obtained from the experiments can be compared with the calculation method. Calculation using area of second is as follows: equation 4 and equation 5. This is the symbol and the meaning including the unit. There is mass, gravity, and others.
Hello and Assalamualaikum. My name is Lutfi Danish bin Khairul Azizi. I want to explain how we conduct this experiment. So this is the methodology of this experiment. As you can see, first of all, you take out the horizontal weight, pitch the height of the vertical weight on the puntun, and then you adjust the thread until it gives an angle of 0. It means we start with the angle of 0 first, no tilt. And then we determine the center of gravity by putting the puntun mass in the mass balance, and we measure the length of CG, which is the length in millimeter. So the next is we fix the horizontal weight, and then we fill the tank with water, so the puntun will float. And then we measure the length of puntun, move the horizontal weight, and we can repeat all the steps and record the angle of tilt, and also we can adjust the height of the vertical weight to the new height and repeat the above procedure. So the next is, this is the result that we got from the experiment. So this is the calculation to get GM is the WX over W tan theta, which is we get the data from this table for each angle that we calculate. And for the first of all, this is the graph that we obtain from the data. We plot the graph to observe. So there are 3 tests. So each test has 2 graphs. So it's have the movement to the right and also movement to the left. So this is the result of test 1. You can see, as we can see here and here. So this is for test 2. And then this is for test 3. So what can we conclude from this graph is that the value of test 1 GM is 0.26 and movement to the right and 0.038 for movement to the left. For test 2 is 0.0469 to the right and to the left, and 0.543 for to the left. And for test P is 0.199 meter for movement to the right, which can we conclude there is an error. For example, in test 3, the right movement is 0.0911, which is too high. This may be due to the error that we tend when we handling the experiment. So the next is we must calculate the value of GM for each test using an area of second moment. So we want to compare the value. So we will use the formula, that is GM equals to BM minus G, that's 1 over P, and that is the formula as you can see in the screen. And we just put the data that we got from last time, and we calculate it for test 1, test 2, and test 3. And as you can see, by using the equation above, we obtain the value of 0.0806, 0.1091, and 0.1336. So the values are significantly different from the experimental values. So, and the equation of aerosolid moment is dependent on the distance of the base of Puntun to the center of gravity. So does the location of the metacenter depend on the location of the center of gravity? So the answer is yes, because the metacenter is defined as the point where the vertical through the new center of buoyancy meets the original vertical through the center of gravity after a very small angle of rotation. So when the body is in equilibrium position, the force of buoyancy, that is Fb, is equal to the weight of the body, W, that is W. So there is action line of the weight of the body. So W will be downward, passing to the buoyancy center, that is B, and the gravity center of body G. So when the puntun is tilted at a certain angle, that like we did in our experiment, the action line of W will not be passing to B anymore, but rather passing to G1, and there is a new buoyancy center. So the next is determination of whether the location of the metacenter varies with the angle theta. Yes, the position of the metacenter will change according to the angle theta. Because when we perform this experiment, as the weight is shifted to the right or left at various angles, this will bring the changes of center of gravity and also the center of buoyancy. So it also can be concluded in the equation of Gm equal to Wx over W tan theta. And based on the relationship above, the metacenter is inversely proportional to angle time. Thus, the smaller the value of angle, the greater will be the position of Gm, and hence it will become more stable in equilibrium or vice versa. Okay, thank you. That's all from me.
Hi and Assalamualaikum. My name is Bahabil Syawali. Today I will present about recommendation and the conclusion. For the recommendation, we have 3, which is the first one, parallax error. The second one is always take the thread at 0mm for initial measurement. And the last one is make sure the plumb box stop before taking reading. Okay, for the conclusion is the aims of this experiment is to establish the height of the metacenter. The metacentric point varies and often depends on the body center of gravity. In addition, the sloping angle brings about a change in the metacentric point. The depth of the submerged puntun does not depend on the center of gravity, but on the puntun's own weight. In addition, the pillar vertical height also influences the center of gravity, which is also affects stability. The second conclusion is the experimental result is slightly different compared to the experimental value and the theoretical value. With the theoretical value obtained from the equation given, due to mistake occurred during the experimental process, we found that on the surface of the water there was movement. Therefore, the puntun was not secure. So, the thread does not place itself on the scale, which creates difficulty in reading, resulting in data inaccuracy. Okay, that's all for me. Thank you.